This is the Swift by Sundell podcast, conversations about Swift development and beyond. Hi, everybody, and welcome to episode number 93 of this podcast. I'm your host, John Sundell, and I'm joined by another fantastic guest. He is an iOS developer at Disney Streaming Services, and he's also the author of two recently released books, Practical Combine and Practical Core Data. It's Donnie Walls. Welcome back to the show, Donnie.
Hey, John. Thanks for having me on again. Great to be here.
Yeah, it's great to have you on again as well. I think the last time we spoke was on the 2019 holiday special, which was a lot of fun, but it's great to do one episode with you, just you and me, talking about Core Data, Combine, and lots of other fun stuff.
Definitely, yeah. I think 2019 was the last time we spoke. It's been a while.
Yeah, it really has. So besides the work that you do on your own, writing books and articles on your website and things like that, you work at Disney Streaming Services. Could you tell us a little bit more about what work you do there and also what it feels like to work for such a high-profile company like Disney?
Yeah, absolutely. So I work at Disney Streaming, like you said. We make Disney Plus, and the fun part is that I don't actually work on Disney Plus, the app. I work on an SDK that powers the application. So that means that my code ensures that our tvOS, iOS clients all communicate with our backend in a predictable manner, that session state management is done correctly and all that kind of stuff. And the nice part is that the SDK is also used in an app called ESPN Plus, which I think American listeners will be more familiar with than European listeners. But yeah, that's what I do. I don't work on UI. I haven't worked on UI for a while professionally. It's weird working on such a high-profile app, but not touching the app, but also knowing that your code does a lot of the very important things, because if I would have a bug in, let's say, the login flow, nobody would be able to log into the app. So it's a funny position to be in with an SDK.
Yeah, absolutely. I think it's fair to say that you are kind of working on the beating heart of the applications, right?
Kind of.
Yeah, like all that kind of core logic. And I think a lot of, especially larger companies, have similar strategies in that they have some kind of core library or core SDK that they use across their different products. Or even if they only build one product, they might use it across different platforms as well to kind of make sure that the logic stays the same. And of course, the benefit of that is that you get some kind of uniformity across platforms and across products. But like you also said, it also kind of presents a risk of if you introduce a bug into that SDK, you have that bug in all of your products or on all of your platforms. So I can also imagine it's quite a big responsibility to work on that SDK.
Yeah, it definitely is. And it's spot on what you say about like introducing a bug, especially also because like if you have multiple clients using a product that you make, you'll find that every client has slightly different use cases, slightly different needs. And that means that what's a bug for one person could be fine for the other, or, you know, maybe the Disney Plus app uses our SDK in some way where, you know, they don't see a bug as often, which is rarely the case because we have fantastic QA people. But, you know, like ESPN, for example, might use it differently and run into a bug like immediately after a release.
Right. You could kind of end up in the classic, is it a bug or a feature, right? Where, you know, for one client, it might be a severe bug. And for another client, they might work around that in some way or, you know, expecting a different behavior, which can be really interesting.
Exactly. Like what one client's bug is the other client's workaround, I guess.
Right, exactly. So how do you typically manage that kind of complexity, if you will? Like when you have all these different teams and different apps kind of using your SDK and using your APIs, I can imagine that you might be getting a lot of different requests from different people. You might be getting, you know, bug reports from people or just like these kind of water cooler conversations, if you will, that might happen on video calls and things these days. But, you know, different developers kind of talking to you about ways they would like you to change your SDK to make their own feature development easier. How do you typically manage these sorts of situations and kind of making sure that your SDK's roadmap stays aligned with the roadmap of the overall products that it's being used in?
It's definitely true that if you work on, well, any framework, I work on SDK, but we have people building all kinds of frameworks and tools. And you'll see that people have questions about it. They run into problems. They want things to be easier or different, so they ask for features. And that can happen like anywhere. It could be randomly in a meeting. It could, like you said, be sort of a water cooler conversation. But it could also just be a serious bug report sent via email or Slack or in a GitHub issue or whatever. And typically what we'll do is, if it's something that is more of a feature request, we'll sort of assess like how useful is this? How important do we think this is? Also, how much risk is there involved with this? Because sometimes people ask for certain caching things or whatever. And as you probably know very well, caching is nice, but it's also a risk because caches can be out of date or be wrong or whatever.
Definitely a double-edged sword, yeah.
It definitely is a double-edged sword. So we'll sort of, as engineers, we'll sort of look at like how feasible is this feature or this request, and then we'll just forward it to our technical project manager, who will kind of fit it into the roadmap from there. They'll talk to the project manager for the other teams, see like how important is it really for the team, and they'll sort of hash out the timing and priority on most features. Of course, like bugs, crashes, all that stuff, that sort of takes precedence over anything, and we'll fix that as soon as possible. But it's usually the project manager who will give the go-ahead on working on it and plan it. So that's really nice.
Yeah, that sounds very good. It sounds organized and nice, right? That it kind of goes through the proper channels so it doesn't become too chaotic.
Yeah, definitely. And I mean, bugs and all that stuff, those can be messy because you'll find that if something goes live in production or is close to being submitted to the App Store, people tend to get a little bit nervous then, and they'll want to have their problems fixed like as soon as possible. And that's when things can be a little bit messy because you don't always have time to properly involve project managers at that point. But it doesn't happen often. So most of the time it's really structured, and I really like that.
Yeah, that sounds really good. So I was actually working in a very similar situation as you when I was working at Spotify. I was working also on internal tools and frameworks for the developers there. And I was mostly focused on the UI. So I was building like UI libraries and working on our design system and components and things like that. And it was a similar situation where a lot of times we would get requests from different teams, to help them kind of bring their features to life using the standard components. Sometimes there was a case where our tools didn't properly support some feature that was needed in order to implement a new product feature and things like that. So there was a lot of requests like going back and forth. And one thing that I tried to do when I was working in that situation was to kind of foster sort of an open source culture within the company around these frameworks, where I tried to kind of encourage all the other teams around the company to contribute to the frameworks that we were working on, because I realized quite early on in this process when we were establishing these teams that we were like 5 or 6 people or something like that working on these frameworks, and they were used by like hundreds of developers. So it was going to be really difficult for us to kind of keep up with all those requests, and we would always kind of turn into like a bottleneck for kind of the overall innovation and the overall kind of product progression. So what we did was that we started kind of going and embedding in different teams and working with different teams and kind of helping establish a culture where these teams also felt empowered to contribute back to these frameworks. So that's what I meant when I said that it was like almost like an open source situation where you could kind of look at it as we, the team that were working on the framework, were the maintainers, but all the other teams around the company could be contributors and send pull requests to that framework. And that ended up working really well, where a lot of different developers like around the company kind of became like almost like an extension of our team, and we could kind of keep iterating on those frameworks together and making sure we had good tests in place and good automation and things like that, and good documentation and good conventions, so that it didn't become too chaotic or that, the framework went in directions we didn't want it to. But it was a really interesting experiment to kind of try to establish an open source model, but within one company.
Yeah, that's definitely a fantastic approach. We do that for some of our frameworks, like most of our UI components and all that stuff. The SDK is a little bit more complicated, especially because that is like used across different applications. So it can be really hard for engineers not familiar with the other apps and their use cases to make changes, because you wouldn't want those changes to be conflicting with what you're doing for other clients.
Right.
But like everything that is internal to our app, we have a ton of different frameworks and components and libraries and whatnot. And those have a culture, like you said, where everybody kind of works on it, but there's a smaller team that owns it, like they're responsible for it, but the other people are contributing to it, improving it, bug fixing, and all that kind of stuff.
Yeah, I think that's really important because you really want the other teams in the company to really feel empowered, right? And to not feel like they can only work in this little silo, this little part of the app, and they can't touch like the shared frameworks, because so much of the functionality over time will probably be implemented in those shared frameworks. So you definitely want it to be a situation where, people are empowered to basically do their job, right? To actually bring the features they want to bring to life, which I think is really important.
Yeah, you also don't want to have like this culture where it's us versus them or something. Like you want your team, even though you're all responsible for different parts, you're still a team that works on the same product and the same goals.
Yeah, absolutely. So you mentioned earlier that one kind of thing that you always have to manage when working on the SDK is kind of the risk and the fact that the SDK is being deployed in multiple applications. Introducing a bug could have some pretty bad effects. So you mentioned that you have a really good QA team that kind of tests everything and makes sure that things are good before you ship. But how else do you kind of manage this type of complexity? And how do you make sure that you have high quality, even though you're continuously shipping new versions of your SDK and of these applications? How do you utilize things like automatic testing and code reviews and those sorts of things?
Yeah, so I've done a couple of talks on like how we manage this stuff in the past. And the main flow for anything we do in the SDK that's high impact, so basically any new features, new business logic, or that kind of stuff, we have a speccing process where one or two engineers will work on a feature specification and sort of write out like how's this feature going to work and kind of define it as UML. So we'll sort of get like a rough class diagram and all that kind of stuff. And this spec is not just for Apple platforms, it's for every platform that we have an SDK on. So that's iOS, Android, tvOS, Android TV, the web, UWP, so it's Windows stuff, like all kinds of different teams. And all these people will review the spec and look at how we intend to build something. So they'll ask things like, hey, so when exactly are we supposed to hit this endpoint? Is it like on app launch? But if it's on app launch, people go as far as like thinking of, if we do this on app launch and we send out a push notification for this new show that's live, everybody will open the app at the same time. Like, is this okay with services? Do they realize that could be thousands or even millions of requests coming in within a second? Like, is that okay with them?
Right.
And that's really good to have all these people who focus on different things and have different like sort of things they're very interested in. You'll typically find in a team that there's this one person who's really great at seeing these kind of mistakes and one person who's always thinking about that. So once the spec is approved and everybody's happy with it, we can implement it. We do a ton of automated testing with Quick, the testing framework on top of Xcode testing. And every pull request is run through CI. It's tested. It's all automated. So typically we'll have pretty good test coverage in the SDK itself. And then before it goes to the App Store, our QA team will do a full run through of the entire app before it's even submitted.
Nice. Yeah, that sounds very good. I really love that you are doing that kind of specification process to begin with, especially since you're covering multiple platforms and kind of the higher level logic of these new features. Because so often I feel like as developers, we kind of start rushing into the implementation. Like we get some ticket or some new feature that we're going to work on, and we just immediately want to start coding it. But one thing that I've been doing for many years now is that whenever I have a new feature that I'm going to work on, I just start by diagramming it basically, right? By drawing out what I think the overall architecture should be. And the interesting thing when doing that process, initially it might seem like almost like a waste of time, or, it doesn't matter because your implementation might change that original architecture anyway because of, the way the system works or the way some other APIs work and so on. But I really find that by doing that initial kind of architectural classic kind of class diagram process, I can find mistakes that I originally made when I started thinking about this implementation really early. Before I've even started coding, I can already discover things like dependencies that go both directions, potentials for like multiple sources of truth or bugs with inconsistencies. I can see all of that when I'm actually drawing things out, because I can see this object here now needs to talk to these 5 other objects, where it would perhaps be cleaner if I build more like a pipeline where instead of this one object having connections to these 5 other objects, there's this intermediate step that these other objects can connect to, or something like that. And I've just found that to be really valuable and actually a huge time saver, not a time waste, where if I just spend like an hour doing that class diagram, I can save so much time later during the implementation when I don't really have to think too much about those things, because I've kind of already solved them, or I've already considered them earlier in the process.
Oh, yeah, absolutely. I typically find similar things in the specking phase, but I'd like to add to that also that, for me at least, doing a very loosely, I shouldn't call it test-driven development, but I always call it test-driven development, but it's loosely based on it. Sort of just writing out a bunch of tests that you want to write before even writing your code, and sort of specifying, like, how do I expect this thing to work, and how do I expect that thing to work, and how am I going to wire up these components? And the one thing that I've found is that you kind of trick yourself into testing edge cases before you even realize they're edge cases.
Right, yeah.
And like, I don't know about you, but when I write tests for existing code and I know something is going to break a test and it's going to be a pain to refactor, I just don't write the test typically.
Right.
But if you already wrote the test, you have to delete the test, and that feels worse than not writing the test at all. So you end up making the code more testable, and in the process, just cover more edge cases and more maybe unexpected flows that you would have not even thought of had you not diagrammed and sort of prototyped it in tests.
Yeah, I think that's a super good point. And it's almost like you're making a promise to yourself in the future, right? You're kind of promising yourself that I am going to write this test.
Exactly.
And I do very much a similar process to you, actually. When I work on libraries and more like my open source projects and things like that, I sometimes work more in a kind of classic TDD fashion, like test-driven development, where I will write the test case first, then I will implement whatever it is I'm going to implement, and then I make sure that the tests pass. But when I work on applications, I tend to follow more like a process like you are using, which I like to call TDD light, which is kind of like, I write the test cases, I kind of define what I want to test first, just like you do, but I don't necessarily make the tests fail first, because I felt like that is a little bit too much overhead for me personally when I'm working on more kind of UI-based things or more things that I need to test not only automatically, but I also need to actually use the application and make sure things feel right. So I feel like that kind of strikes a nice balance. So I'm really glad you bring that up, because I actually follow a very similar workflow.
Yeah, for sure. And also like doing the whole red-green thing, it can feel so tedious and trivial if you have like 5 tests that just test 5 different inputs. And you just want to make sure that you get the right string back or whatever. Right? Like you put in an enum and then format it into a string, make sure that it's the correct one. Like, why would I test that one by one and not just all 5 at the same time?
Exactly. And this is the point where like the TDD purists, like the people who are really, like they always want to write just like pure unit tests, they will be angry at us now for saying this. But I do agree with you. I think you have to be a little bit pragmatic about your testing. Like it doesn't have to be so extreme. Like you can write tests that are perhaps by definition a little bit more towards the integration tests end of the spectrum, where you are testing one class and the different things that it uses and talks to. So things like model classes and enums and things like that. I tend to test those all in one go, because what I'm actually looking to test at the end of the day is the end result, like the functionality that I get out of it, not necessarily like, is this enum raw value exactly what I expect it to be? Because I found that if I write tests that way, like on that super granular level, not only do I end up with a large number of tests, but also I feel like I'm kind of writing my code twice. I feel like first I'm writing my enum, and then I'm writing the test that verifies the enum. It feels kind of redundant.
Yeah, for sure. I do tend to sometimes go into redundancy when it's about like the core business logic, right? Like if this is the one thing that the business is going to make money on, I better make sure that I test it, even though it feels tedious.
Always test the money code path. I think that's good advice.
Oh, yes. Yeah. Like You better make sure that that has all the coverage you can give it.
Yeah, absolutely. So besides working on tests and working at Disney streaming services, you are also writing blog posts on your website, and you're also writing books now these days. So I think it's been really impressive to see that you've been releasing 2 full-length books in a relatively short period of time. Like, I believe when you were last on the show, you were just wrapping up your work on Practical Combine, but now you've not only released Practical Combine, but you've also released Practical Core Data as well. So I'm curious to hear, like, what does your book writing process look like, and how did you manage to kind of get 2 full-length books out in such a kind of short period of time?
Yeah, that's a great question. I don't know either. I think I may have found like a loophole in how time works or something like that.
You found a time portal. You can bring the book back to yourself.
I think so. No, kidding aside, it's so the Combine book. I sort of started working on that in my head when Combine was released. So that one was actually probably like eight or 9 months in the making before it was released, of which only 2 or 3 months were spent writing. And then the Core Data one, actually, I first thought of it in 2018. I started thinking about, like, Core Data has not a lot of content out there, and it has a lot of people disliking it.
Mm-hmm.
So it was probably it was February 2019 when I did a talk at TriSwift Tokyo, for example, about Core Data. And that one was received really well by a lot of people that said, thank you. Finally, someone who, is sort of talking about Core Data and showing what it can do and, saying something different than, oh, it's a terrible framework. You shouldn't use it. You should use some third-party solution. And for me, that was like, okay, so that's good. I should work on this book. And then life happened and I didn't really work on it a lot. And then I worked on the Combine book. And then when the Combine book was done, I was like, okay, this was fun. Let's do the Core Data one next. So I kind of just slowly started working on it. And because I had been thinking about it for so long, working on the book was, I'd almost say that it was easy because, I had a year to think about what I wanted to write down.
Yeah, and presumably you also had a process kind of established at that point, right?
For sure.
Like you had already gone through releasing your Combine book, so you could kind of replicate the same process with your Core Data book, because so often what I found personally is that doing like the first product or the first thing that you're producing, whether it's an article or a podcast episode or whatever it is that you're producing, like the very first one will always take so much more time because you have to kind of figure out the process first. But then once you have the process going and you're kind of established a workflow, like doing additional content and doing additional products is usually like much less effort.
For sure. Yeah. And also like not a lot of people have read the books, but I wrote a book on iOS 10, iOS 11, and also one on iOS 12 before this for a publisher. So I had the process of writing a book pretty much nailed at that point because Practical Combine was my 4th book in total. But it's the first one I self-published. So there was some stuff to figure out there. But, how to write a big story almost and how to sort of structure that and ease people like into learning and, going deeper and deeper down the rabbit hole. I kind of had that figured out a little bit from the previous books too. So that helped a lot.
Right. Yeah, that makes a lot of sense. So both of your books, they have this prefix practical, right? Which I think is really great that you're focusing on giving practical tips and teaching these technologies from a practical point of view, because sometimes when we discuss technology, it can get a little bit theoretical. And I also really, really try to focus always on practical use cases, like not only that this technology is cool, but how can we actually use it to build good products? So that's what I would love to focus on for the remainder of this episode, is to share a lot of practical tips on both Combine and Core Data. So to kind of stick to the themes of your books, which I think is going to be a lot of fun. But before we dive into those topics, let's take a very quick break to thank this episode's first sponsor, which is a new sponsor that I think you're really going to like. Emerge, which is a new tool that can help you drastically reduce your app's binary size. Now, that might not seem like the most important metric for you to optimize as an iOS developer, but reducing your app's total size can have a quite substantial impact on the overall experience of downloading and using your app. Not only will a smaller, more optimized app be faster and easier for your users to download, but reducing your app's size can also often make it launch faster and even improve its overall performance. So what exactly does Emerge do? The way it works is that it integrates seamlessly with either GitHub or Fastlane, and then every time you make a change to your app and open up a pull request, Emerge will scan your app and produce a report that shows you how that change will impact your app's final binary size. But that's just the beginning, because Emerge will also give you concrete actionable suggestions on how you can then reduce that size as well. From simple things like stripping out unnecessary image metadata and removing whitespace from text files like localized strings, to detecting duplicate or unused files, to advanced code level optimizations like removing unused symbols and unused code level metadata. All of this will be presented right there as a comment on the pull request itself, which gives you constant and immediate feedback, which is so incredibly important in order to be able to perform optimizations like this over time and to keep your app's size in check as you're iterating on it. If this sounds interesting to you, then make sure to check out Emerge today by heading over to emergetools.com. There you can find a lot more information, and you can even see a demo right there on the website that shows you exactly what sort of information and optimization suggestions that Emerge can provide you with. Then simply click the Get Started button, and the team behind Emerge will personally help you get started with it. Once again, that's emergetools.com, and there will be a link in the show notes as well. Thanks a lot to Emerge for sponsoring this episode of Swift by Sundell. Alright, so now let's dive into Combine and Core Data, and let's start with Combine. So Combine, of course, was introduced alongside of Swift UI in 2019 by Apple. It's Apple's own reactive programming framework, and it's been really interesting to see the community adopting it, both in the context of Swift UI, but also outside of Swift UI as well. So I wanted to start by discussing one topic that I feel comes up quite a lot when we talk about Combine, and that's how to avoid having a Combine pipeline grow too much in complexity. Because when you start with Combine, you might start by writing your code almost like you would when using completion handlers and closures, in that you are just creating one publisher, which emits some values or maybe an error, and then you erase that to any publisher and you return it. And that's kind of your Combine pipeline. But then as you learn more about the framework and you learn about the operators it has, you learn about things like flat map and map and how you can kind of spin off other kind of sub-pipelines that you then bring back to your main pipeline. And you can almost write your code in a way where everything is implemented as one large pipeline, which can look really elegant when you look at the code, but then debugging it can be a little bit difficult, or getting an overview of that code as someone who didn't write it, like when you're looking at it for the first time, can also be a little bit difficult. So how do you typically strike a balance between those two kind of extremes, like either having almost no logic in the Combine pipeline and just using it as a kind of wrapper for a closure, and on the other end of the spectrum, having everything be implemented as Combine operators? How do you typically balance those two things?
Oh, that's such a tough question. That's almost, and I think that also is a nice segue into a good answer. It's almost like asking, I have all these free floating functions and variables. How would I structure my code? And you would say, well, have you tried using classes?
Right.
Combine is a functional reactive programming framework. So that means that it draws a lot from functional programming. And in functional programming, you have, of course, a lot of ideas and principles. But one of the important one is that you group functionality into functions instead of classes. So if you have a very long pipeline, you're basically calling a lot of operators, on each other. Like you have map, flat map, and then maybe another map, then maybe replace error, then maybe retry, then maybe debounce. And you could say that is typically maybe a function that just does too much, right? So what you could do is split it up into smaller functions that you define as operators. So you could, create an extension on publisher and then be like, extract response and replace errors. And you could put that in place of 3 or 4 operators. And then your pipeline would become something like fetch data, extract objects and replace errors, write to persistent store, erase to any publisher. And if you would see that in a function, you'd be like, okay, this does like 3 or 4 things to my data, and then it returns it. Easy. So that's what I would suggest. Like, try to create some extensions on publisher that are useful for you.
Yeah, I think that's really good advice. And not only can that help make your code easier to read and easier to kind of get an overview, but when doing that, you're also kind of continuously building up this library of your own operators that you can then reuse across your code base. So chances are pretty high that if you, for example, are performing a filter and you're removing like all the nil elements that the publisher will output or something like that, or you are, like you say, like storing the value in a persistent storage or caching it or something like that, chances are that you will not only want to do those things in one place, but you will want to do them in multiple places. And by encapsulating that logic into your own quote-unquote operators, which is really just extensions on the publisher protocol, which then performs your logic and returns a new publisher. So it does work exactly like the built-in operators do, like map and flat map and these sorts of things. You're kind of building that library for yourself, which makes it easier and easier to then write combine-based code in your app, which I think is a great investment. So it's kind of both serves the purpose of structuring and making your code easier to manage, but it also lets you kind of continuously build up reusable functionality within your app.
Absolutely. And also, you mentioned debugging and that kind of stuff. And having these small operators also makes your combined code so much easier to debug. And that's not necessarily because it's fewer operators, so it's easier to see what might be wrong, but you can write your tests for these operators. Like if you have an operator that is expected to, take the output of a networking publisher or a data task publisher and do things with that and then return something, you could write a test for that custom operator to see that, okay, if I get valid data, I want this to happen, I want that to happen. And you only test these small things that should happen in that pipeline. And if that works, then you know that that step in your pipeline is not going to be the problem. Unless you didn't test it thoroughly, you need to add more test cases.
Exactly. Yeah, I think that's a really good point as well. And it also really relates to what you said earlier, that Combine really leans into some of the principles of functional programming in that everything, all of your code and your operations kind of become more atomic, which also means that you can test them in isolation as well. And another thing that I've found to be really useful when working with Combine is if you end up doing a lot of work kind of inline enclosures within your Combine pipelines, so you perform, for example, a map and you want to convert the output of one publisher into a new value, and you write that as a closure within your actual code, it's very, very common to end up with compiler errors where the compiler says, I can't type check this in a reasonable amount of time, or you have to add explicit types to this closure in order for the compiler to, figure out what it is that you mean. And whenever I get one of those errors, that's a signal to me that this should be broken out into something else. I don't want to be doing this work in an inline closure anymore. I basically just use inline closures for super simple value transformations. And then whenever I have anything relatively complex, I break that out either into a custom operator, like we mentioned earlier, if it's something reusable that can be used with multiple kind of pipelines and within multiple features. But if it's something that's very specific to this thing that I'm doing right now, I might just break it out into a private function within that file. So I will just delegate this map call into that private function. And that way I'm kind of going away from this declarative Combine pipeline and back into the imperative world of having just my own function that executes from top to bottom. And within there, I can put if statements, I can put different return statements, I can put whatever logic I want in there without having to pay the cost of having to annotate everything with explicit types because I'm working in that heavily generic context that a Combine pipeline is. So I also feel like having that technique at your disposal as well, like being able to break things out into more classically defined functions or methods, is also like really, really useful.
Yeah, absolutely. If you could see me right now, I'm like nodding my head very intensely.
That's perfect. So sometimes when you do break up larger combined pipelines into these more atomic operations, you do sometimes need to also merge them. So if you, for example, you're fetching like an array of IDs, for example, from your database or from your backend, from your server, and then you want to, for each of one of those IDs, you want to go and perform another kind of asynchronous operation. Maybe you are fetching some different model or you're annotating them somehow or something like that. What are your typical strategies for implementing that sort of functionality, like when you have one pipeline then kind of branches out into multiple pipelines, and then you have to combine them, like the framework is called, back into that original pipeline and the original data. How do you typically manage that sort of functionality?
So the typical flow for me would be to start with flat map, right? Because I'm taking a publisher, and then taking its output, and then I'm starting a new nested pipeline, if you will. So that is step one, like write a flat map and return a new publisher that does what you want to do. And ideally, you don't want that flat map to be like 20 lines long. So if you end up with more than like 4 or 5 lines, you're probably going to want to pull this out into a private function, or maybe, create your own little kind of class or whatever that you could return something from. Ideally, I would say create a private function, because you don't want to go through the hassle of building a custom publisher just for this kind of stuff. It's a lot of work to properly implement a custom publisher. So return a publisher from that flat map. Now then, if let's say you have this list of IDs and you want to load a bunch of data, and then only proceed once all of this data is loaded, right? So you get IDs, fetch all these users, maybe make 10 API calls, and then in your sync, in your subscriber, you want to receive all 10 entries at once. In that case, you could throw a collect operator after the flat map, and that'll just keep collecting output until the upstream publisher completes, which is the list of IDs, and then you get that list of output in your sync. So that's one approach that I would take. But I always try to sort of think in terms of what are the building blocks in Combine that I can use to build this, and what are the rules. And as soon as I find that I start to fight with Combine, I'm like, maybe Combine is not the best solution for this specific problem then. Because one question that I get asked a lot is like, how would I do this API call, then that one, and then make like 4 or 5 API calls serially, and then like do 6 of them parallel, and then one more serially? It's like, well, that is an operation queue. That's not a combined pipeline.
Yeah, I think that's a very good point. Sometimes when we get excited about these technologies, we want to use them for everything, right? But sometimes they are not the right tool for the job. And there's a reason why Apple's SDKs and the overall kind of platform has so many different ways of accomplishing similar things. Like asynchronous programming has Combine, of course. You have Grand Central Dispatch, you have operation queues and operations, like you just mentioned. Like there are many different abstractions we can use. And I think picking the right one for each problem is really key. Instead of just saying, I'm going to use Combine for everything. I get it that it kind of feels that your code becomes a little bit more uniform and consistent when you use one abstraction for everything, but it can also lead you down a path where you are fighting the tools, like you just mentioned, where you're trying to kind of shoehorn this technology into a problem that it clearly wasn't designed for, or that it clearly like isn't ideal for.
Absolutely, yeah. And there's another example of that. Where a lot of people who use PromiseKit, I assume you're familiar with the library.
Yeah, for sure.
Yeah, and a lot of people use that library right now, and they're like, oh, Combine could totally replace that. And then soon they find that PromiseKit has really nice APIs to chain all kinds of operations together, like one after one after one, like I mentioned earlier, that you normally would do maybe an operation queue. And you find that people try to translate that one-on-one, and they're like, oh, Combine is so frustrating because it's not PromiseKit.
Yeah, also a great point as well, because even though Combine does have a future type, which you can kind of use similar to futures and promises, it's not a futures and promises library, right? So if that's the abstraction you want to use, you're better off either like implementing your own futures and promises or using something like PromiseKit. I think that's also a really good point, like to not try to make Combine be something it's not.
Absolutely.
So you mentioned earlier that building your own publisher is kind of a lot of work, and I do agree with that. And it can sometimes be a little bit hard to get things right when it comes to like managing subscriptions to your publisher, making sure that values are emitted in a consistent manner, and so on. And one thing that I found really useful when you need that sort of functionality, like when you want to gain pretty good control over how values are sent downstream, to other operators and ultimately to the subscribers of your pipeline, I'm using subjects a lot for that. So whenever I have a situation like this, when I want to collect different values perhaps, or go off and do something in a background thread and then later bring those values back and send them to the subscribers, I will typically create a subject, like a pass-through subject, and I will then do my work, and then I will send the values into that subject, and I will return that subject erased to any publisher. So the callers of my API don't know that they're dealing with the subject. They're just dealing with any kind of publisher that they can write any sort of operators on and things like that. But under the hood, I'm using a subject rather than having to implement my own publisher completely from scratch.
Yes, that is perfect, I would say. It's exactly what I recommend most people do. It's also what Apple recommends that people do. Apple basically in their documentation said, like, if you're considering writing your own publisher, you probably want to use a subject.
Right, exactly, because it just provides so much functionality for free, and you can usually accomplish exactly the same things with a subject that you would with a custom publisher as well.
Absolutely. It's only in like very specific niche kind of things where maybe a custom publisher is nicer, but in general, if you have your subject and you erase it to any publisher so nobody knows what it is, and if you don't want to return like any publisher, create a type alias, just fake it.
Right. Fake it until you make it.
Exactly. And yeah, that's what I do too. And I have not run into any issues with that. It's nice. It's consistent. You don't have to worry about memory management. You don't have to worry about back pressure. You don't have to worry about like getting all the details right, because that is all, encapsulated in that subject.
Yeah, absolutely. So the final thing I'd like to discuss with you on the topic of Combine is testing. So we talked about testing earlier, and we touched on it a little bit when we talked about our custom operators and how we can test them in isolation. But since Combine does not really ship with a lot of kind of affordances or convenience APIs for testing specifically, how do you typically test code that uses Combine? Like, have you written any kind of your own utilities and things like that for testing Combine code, or how do you typically deal with that?
So I've not really written any utilities that are extremely complicated or convoluted, in the sense that I would not open source them, basically, because they're too trivial. So what I've seen people do and what I've seen people ask for is a test scheduler, and that is mostly useful, I think, for time-sensitive things where you want something to run for 10 seconds and then see how it works. That kind of code, in my experience, is not super common, at least not in code bases that I work on. So what I'll typically do is, if I have a publisher that completes, I will, subscribe to the publisher and, use Xcode's test expectations and see whether the output is what I expected it to be. If I expect the publisher to output multiple values, I'll just collect them all in an array and then, do an assertion on the array after the publisher completes. If all's good, test passes, expectation fulfilled, everybody's happy. If it's a publisher that does not complete, like it's going to run for a while, I'll just sort of know, like, okay, I expect this publisher to emit values over a course of some time or whatever, or, to eventually get this number of values. And I'll just use test expectations. I'll collect the output for as long as I need. So if it takes 10 minutes to output 10 elements, my test would run for 10 minutes in the worst case. And I'll just collect the output. And once I get the output I expected, I fulfill the test expectation and the test passes. So it's all based on Xcode's test expectations, really.
Yeah, I also use Xcode's test expectations as well. I think they're a really powerful tool in general for testing asynchronous code. I think the collect operator that you mentioned there is really, really useful when it comes to testing, where you can both call collect and get an array back of all the values that were outputted by a given publisher, but you can also tell it to only collect a certain number of items. And that's really useful for publishers, like you mentioned, that don't complete. So if you have, for example, an @published property and you want to test, you are performing some kind of call and you want to make sure that the published property is changed and that it emits a new value, that publisher will never complete because it's just a property that can keep emitting values forever. So then specifying a number of items that you want to collect is really useful, because then you can say, give me the first 3 values that were emitted, and then you can check that they are what you would expect. And the only thing that I've written really in terms of kind of infrastructure for myself is that I've written an extension on XC test case that lets me await the result of a given publisher. So it's almost my little own version of async await. And I have written an article about that we will put in the show notes. But it's been really useful in multiple projects where if I just want to await either a collection of outputs using the collect operator or just a single publisher, to not have to always do that dance of, create an expectation execution, sync the publisher, manage the cancelable, fulfill the expectation. Like that await function does that for me and gives me a synchronous API for calling that publisher, which is really useful in a test context, I think.
I think I read that article, and I believe your approach was similar to sort of like RX's to blocking operator, for example, where you basically just say like, hey, block this thread and wait for the publisher to complete, or in RX's case, observable to complete.
Yeah, I think that's really useful in a test context where you do want things to block because your test is synchronous, right? So you need to wait for things, and that's what expectations are great for. But, if you can write a little kind of convenience API on top of that to make it even easier to do that sort of thing, if you're going to do it a lot, then that can really be a nice kind of quality of life improvement, if you will.
Absolutely, yeah. It's just a little bit of boilerplate. It's just a couple of lines, but it's nice to not have to write them every time.
Yeah, absolutely. All right, so now let's segue into our second main topic for this episode, which will be core data. But before we do that, let's take another quick break to thank this episode's second and final sponsor, which is my good friends at Bitrise. Bitrise is, without a doubt, my favorite way of implementing continuous integration for Swift projects. I've been a really happy Bitrise customer for many years now, since long before they became a sponsor, and I continue to use it all the time, both for my own projects and for client projects as well. What I love about Bitrise is that it lets me set up things like automatic testing, continuous deployment, and distribution of beta builds really easily, and once I've finished setting it up, then it just keeps working even as new versions of Xcode are released. But at the same time, Bitrise is not one of those black box type of services where you can't see what goes on under the hood. You can customize it as much as you want. You can also tell it what type of operating system and Xcode version to run your CI on, and you can also install and run custom tools and scripts and much more. But if you're just looking to get some automatic testing up and running for your project, like what me and Donnie talked about earlier on this episode, then you don't have to worry about any of those things. You can simply head over to bitrise.io/Swift. You can sign up with your GitHub account, and then with just a few clicks, Bitrise will automatically scan your project. It will figure out a good set of default build steps to apply to it, and it will then immediately start building and testing your app. It's really that simple. And now, Bitrise also supports a suite of powerful add-ons that lets you take your continuous integration to the next level, again, with very little effort on your part. Their Ship add-on lets you automatically ship new versions of your app to both TestFlight and the App Store, and it will manage all of the complexities involved in doing that for you. The new Trace add-on then lets you add powerful crash reporting and performance monitoring to your app, again, completely automatically. And the Test Reports add-on gives you a really nice dashboard that shows you the results of all of your automated tests. Some of these add-ons are currently in beta as of this recording, but they're still very much worth checking out. So Bitrise does so much more than simply give you a build server to run your code on. It can help you implement really solid and powerful continuous integration in minutes or hours instead of days. So for me as an indie and as a freelancer, that's such a huge win, which is why I personally use Bitrise for all of my new projects. Head over to bitrise.io/Swift to learn more and to help support this podcast. Once again, that's bitrise.io/Swift, and you can find a link in the show notes too. Thanks a lot to Bitrise for their continued support of all of Swift by Sundell. All right, so now let's dive into our second main topic, which is, of course, core data, which is also the topic of the second book that you wrote as well. It's almost as if we planned this, Donnie, to be synchronized between your books as well. So core data, I think, is interesting in a sense where, like you mentioned, there's a lot of people out there who don't like it, and there's a lot of people who maybe have misconceptions about what it is, or maybe they haven't used it in a while and it has since evolved into something different and so on. It has gained a lot of new capabilities. So perhaps we could start with a little quick recap of what core data actually is and how it can be used.
Yeah, absolutely. So by its definition, core data is a graph management tool. And so what that really means is that core data sort of allows you to define your application's models and data structure, and core data will sort of manage that for you. And what manage means here is that, for example, if you would have an entity employee and you have an entity department, and employee and department have a too-many relationship where one employee can be part of multiple departments, if you would assign an employee to a department, then core data will make sure that on employee, the department is also set. So it will sort of make sure that every relationship you have works two ways. That's just one of the things it does. It also performs validation, for example. Like if you say every employee must have a name, and you try to save or persist an employee without a name, core data will, tell you about it, and it'll refuse to write to the persistent store. And the persistent store in this case is really almost sort of a implementation detail. Of course, we all rely on it, and we all know core data is going to persist to disk, and we use it because we want to persist to disk. But the idea of core data is not that you finely tune or manage or worry about how that persistence happens exactly. And so that's where a lot of people go wrong, because they're like, oh, core data is an SQLite wrapper. As soon as you go in with that mindset, you're setting yourself up for trouble.
And I think it's even explicitly mentioned in the documentation that core data is not a database, right?
Yes.
And I think that's where a lot of this confusion happens. It was incredibly confusing to me when I first started reading the documentation for core data many years ago, where I was like, I was expecting it to be a database. I was coming from backend development at the time, and I was kind of, like you said, I was expecting it to be an SQLite wrapper. And it really isn't. Like, I think the way you describe it, you're saying that it's a way to kind of manage a graph of data. That is way more accurate than thinking of it as just a database wrapper.
Absolutely, yeah. And so I do still find it hard to think of it like, so what is core data then, if not a database? Because it's kind of a database, but I think the key is to sort of throw all your notions of what you know about a traditional relational database, throw it out of the window and learn core data for what it is.
Yeah, it's kind of relates to what we were talking about earlier about like taking a technology like Combine and treating it as if it's futures and promises, right?
Exactly.
It's kind of similar here as well. So like we mentioned earlier in the episode as well, the opinions on core data are in general a bit divisive. In a way, it's kind of similar to how storyboards are adopted by some and rejected by others. Apple tends to end up in the situation with some of their tools that, some developers love them, some developers don't. What do you think that is for core data in particular? Do you think it comes down to that kind of misunderstanding that it is a database, or what do you think that the opinions are a bit divisive about it?
I think there are multiple reasons, and I think the original reason is just that core data was a bit of a pain to set up and understand, especially back when we only wrote Objective-C, and I think, it was until like iOS 10, so iOS 9 and below, core data was a bit of a mess. It was really complicated to set up. You had to create your persistent controller, you had to create your object model, you had to do everything yourself and manage your managed object context yourself, and it was very fiddly and very easy to get wrong. So in iOS 10, Apple actually introduced NS persistent container, and now you can set up your core data stack in, I believe, 2 lines of code if you are okay with a closure being on a single line. So that really changed a lot in terms of like how hard it is to set up core data. And then another one is that people tend to forget that core data objects or managed objects are not thread safe. So that means that you cannot just fetch something in a background thread, throw it into the view. And one thing that I would like core data to do is to crash by default if you do that. Unfortunately, it doesn't. And it works well a lot of the times. So a lot of times you won't get crashes until you do. And then you're confused because you are working on this app for 4 months and now it crashes every time. Why? Well, the reason is that probably you have one more dispatch queue and now things are moved to a different thread, because another interesting detail is that threads and queues are not necessarily the same thing. So there's a chance that you have 2 queues running on one thread, and if that happens, core data seems to be okay with it. It's all complicated details that I'm sure I get wrong all the time in my head too. But the key is to always make sure that you wrap access to managed objects and managed object contexts in a perform block. And perform simply takes a closure and it runs the contents of that closure on the appropriate queue for that managed object context. And all your threading problems are gone.
Yeah, absolutely. I think that's a really good tip. And it's interesting because what you're talking about here and like having a dedicated queue for accessing your data model and mutating it it's kind of just like general good practices when it comes to concurrent multi-threaded programming. Like you can get these sorts of data races with any technology. So it's not specific to core data at all. It's just that I feel like when we have a tool like core data, which is pretty high level, like you say, you can set it up with just a few lines of code these days. You can have this like nice visual editor in Xcode where you can set up your data model. Like everything is very high level and kind of somewhat easy to get started. But then when you end up with these more lower level errors then, which, threading and these sorts of things kind of are, then it kind of breaks this illusion of the framework being very high level. And we see this also in contexts like Swift UI, for example, when you can get some really like heavily advanced generics error when you were just trying to set the background color of your view, right? And this is a problem in general, I feel like, with more higher level tools when you need to be somewhat aware of the kind of complexities that are going on under the hood, in this case of threading. So I think that might just be that disconnect where it doesn't matter which persistence framework you're going to work with, you are going to have to manage your threads and make sure that you're updating things in a consistent way anyway. And core data does offer an API to do that. You just have to be aware of it.
Absolutely. And what I find interesting is that a lot of people say that Realm is easier, but in Realm, like you said, it's the same thing. You need to create a Realm on the thread where you're going to use it. You cannot create a Realm instance on the main context and throw it to the background. That's going to go wrong.
Yeah, exactly. Because if these tools were to handle that for us completely, like if they would always sync everything with their own internal thread, then that would be way worse for performance, right? If you would always need to dispatch all of those things asynchronously and have locks and things like that in place, like to prevent these kind of data races, that would make these databases unacceptably slow, I believe. So there's a good reason why they're designed this way. We just have to know about it.
Yeah.
So what are some other kind of good practices, in your opinion, when working with core data? Like, for example, in order to manage its complexity and how to kind of make the most out of the framework itself?
Yeah, that's a great question. So one thing that I used to go back and forth on a lot, and I think I've settled on a thought there, is don't fight the framework too much. Actually, the other day I had a conversation with someone who was like, well, core data is not great because its models are not struct. It's like, why should models have to be struct? It's like, well, models should be immutable and I should be able to pass them around to other places and then modify them and not have the main thing be changed. Well, okay, that makes sense. But in core data, you have your managed object context, and every object that is managed by this context is unique within its context. So it would not make sense to have two instances represent the same data within the same context. If you want to have what you want, which is an isolated scratchpad, you create a child context and work in there. So that is more complicated than just passing a structure around. I definitely would agree with that. But it's also just not how core data works. That kind of comes back full circle to what we said earlier, and that's like just learn the framework on its own merit instead of wanting it to be something that it's not. And I'm not saying you cannot have a database that is struct-based. It's just core data isn't one of those.
Yeah, and you always have the option also of creating your own structs to represent a temporary piece of data. For example, if you want to have some kind of editor where the user can make local edits without always writing those changes directly to the database, you could create a struct that represents that kind of editing session. And then when the editing session is finished, you write that back to your core data managed object, which again goes into the database and gets persisted. So again, I feel like it's not really a flaw of the framework itself that it is not struct-based. And it makes sense that it's not struct-based because it's written in Objective-C, and Objective-C does not support those kinds of structs that we have in Swift. So that makes sense. But I feel like it's just something that we can manage on our own just by copying that data to some kind of temporary storage, which can totally be struct-based, and then write that back once we're finished.
Yeah, but even then, personally, I would recommend to not go down the struct route. Because if you're going to use core data, some people are like, I don't want my data thing to be all over the place. And I kind of agree with that. But at the same time, realistically speaking, how often do you switch databases? It's like the memory of your application. It's like the brain of your app. How often do you pull it out and put in a new one?
And if you do, you're going to have bigger problems than, where your core data models are being used, right?
Yes, you're going to be in for weeks of refactoring anyway. But so what I prefer to do is if I want to have that scratchpad, right? If I want to have this edit view, I like to have edit views that can be both add and edit at the same time. So what I do is I create a child view context, so that it's just a managed object context that sits below my view context. And I can load a copy of the managed object that I want to edit into that child context, make all the changes I want. If I'm not happy with them, I discard the child context, I discard my view, and all is good. Nothing was changed in the main context. If I want to persist, I just save the child context, boom, changes appear in the view context. So you don't even need the struct, and just creating structs is what a lot of people do, but they do end up throwing a lot of core data's optimizations out by doing that.
Yeah, absolutely. And you can also end up with a ton of code duplication as well. Like you have to basically write your model twice. So I do agree with you that I would probably use the struct approach if I have something very specific that I want to only be used with values, and I only want to use a specific piece of data from my model and then like mutate that as a struct. But if you want to actually inject your whole model, then I do agree that it's probably better to keep using the core data infrastructure, but create that child context instead. And I think it's important to remember also that going back to core data is not a database. Core data is not an SQLite wrapper. You can have a core data context that is in memory, right? You can have a core data context that just lives in memory. It's not persisted until you tell it to. And this is also how we can write tests against core data as well, where we can create a context in memory. We can use our objects just like we would in our production app, but we don't actually persist them or load them or save them from disk. We are just keeping everything in memory, which is also really useful for these sort of temporary contexts that you just want to work on in memory without writing them to disk until the user says save or something like that.
Almost. I'm going to have to correct you there a little bit, John. Wow, this feels good to finally correct you on something because you always know everything so well.
Sure.
No, so in core data, it's either like the whole stack that you have in memory, which is useful for testing, or you have your stack persisted. But every context, every managed object context, by its definition, lives in memory.
Right.
So that's why if you create a child context, it's not persisted to the persistent store until you explicitly do that. So even if you would change like all kinds of things in your main view managed object context, it's not persisted until you save it. So everything you do essentially in a managed object context is in memory until you persist it to the persistent store. And the persistent store could be XML based, it could be a binary format, it could be SQLite, or it could be in memory. So that's just, you mentioned context there, and I thought it was important to make that distinction for anybody who's confused about that.
Yeah, absolutely. I think that's a very good clarification. That's sort of what I meant, but I do appreciate that clarification because, yeah, it doesn't get saved until you explicitly save it. It's not, again, a direct relationship between the changes you make in your model being directly written and read from the database, which would also be pretty bad for performance, right? Like if you would always go directly to the database to fetch the data and write the data immediately, that would also have a lot of overhead to it that you probably don't want. And where something like core data or other tools like it have a huge advantage over something like user defaults, which doesn't work that way, where if you write a value to user defaults, it used to be that also it wasn't saved until you save it, but now it does get saved pretty much immediately. It does happen sometimes asynchronously and things like that. There are some details there to be aware of, but when working with something like core data, you have more control over when something gets saved and when does it get loaded.
Yeah, absolutely.
All right, so now we've discussed a few different aspects of core data, but Donnie, I can't let you go here on this episode without talking about the big one, which is, of course, data migration. And this is another one of those things that can really become complicated if you're not careful, and it can also lead to data loss if you're not careful as well. So it's a really tricky thing where if you want to add things to your data model, if you want to migrate existing users to that new data model, do you have some tips for our listeners here today? Like, how can you manage your core data migrations in a good way?
Oh, I have tons of tips. Let me preface this by saying any data migration is complicated. It doesn't matter if you use core data. It doesn't matter if you have your backend team do the migration. It doesn't matter if you would write codable models to disk directly. Migrations are painful.
Yeah.
They just are every time. So there's no way in core data to say, hey, core data makes migrations easy. It makes them as easy as possible, but they're not easy. So if you add a new property to a model and it's an optional property or it's a property with a default value, core data will happily migrate for you. Do make sure that you create a new model version because Core Data is clever enough to even migrate automatically if you didn't create a new model version. So it'll just take the current SQLite or current persistent store that you use, your data model, compare them, be like, oh, okay, so I need to add a field here, drop one there. Oh, that entity was renamed to something else. It'll just do it for you. You will be unhappy if you do that all on one model version. So every time you ship your app to users, make a new model version when you make changes so that you know that, if a user is on data model 2, you know exactly what's in it, instead of being like, so data model 2 had this change, that change, that change. I deployed here and then I made some more changes to model 2 and then I created model 3. That's going to be messy. You don't want that. That also, try to migrate as few times as possible, because anytime you design a database and you know that, in the future we're probably going to want to add this field or add that field or change this relationship, if at all possible, do it as soon as possible. If you can do it on your first model version, do it on your first model version. Even if you don't assign anything to every value all the time, if you know that you're going to want to do this half a year from now, why not put it in your data model today so you don't have to migrate later? Also, if you can get away with it, nuke the database, create a new one, do that. Don't migrate, just nuke. Why do I say that? Core Data is used as cache a lot of the times, right? So in a lot of apps, you'll see that the backend manages all the data. You fetch it from the server, you store it locally, you make sure that you have offline capabilities. Typically, this is not data that is created on the device. So if you would delete it and fetch it again later, it's not data loss technically. So for a simple migration, of course, do the simple migration. But if you change everything, and it would be a very complicated, painful migration, you can totally get away with nuking and reloading from the remote.
Yeah, because in situations like that, like you mentioned there, it is worse to have inconsistent data than to remove the data, right? Because you don't want to end up in a situation where you have one source of truth on the client that is different from the source of truth on the server. It all really depends on where is the original kind of source of truth, the original storage of the data. Is it on the client or is it on the server? And if you are using it in a way where you're kind of just mirroring your server data, then I do agree that, removing the data you have, if you're significantly changing your data model and just reloading it back from the server, if that doesn't result in any significant data loss, is probably a good approach here. And I also agree that versioning is always key. And again, it doesn't matter which framework you're using. If you're using Core Data or something else, versioning your models is always really key, and having a very well-defined set of versions instead of, like you're saying, adding things and having these sort of new versions, but they're not explicit new versions. That is really going to become messy. So really having a little bit of a plan for your data models and try to plan ahead, like you also said, I think is also a really good tip. So yeah, I think those are some really good tips in general and good advice on how to handle migrations, because like you say, it doesn't matter if you use Core Data or something else. It is going to be a little bit painful. You are going to have to think a little bit extra, ahead of time, because you're dealing with, a potentially almost infinite number of copies of different data on different users' devices that you then have to manage centrally within your code.
Absolutely, yeah. So yeah, like you said, none of the tips I just gave were unique to Core Data.
Right, exactly. And I think that's a good way to wrap up this episode. So I want to thank you so much, Donnie, for taking the time to talk to me today. It was a lot of fun to talk to you about Combine, about Core Data, and about your work at Disney Streaming Services. So thanks a lot for being my guest on this episode.
Yeah, thanks for inviting me again. It was a ton of fun to talk about all this.
Yeah, it really was. So if people now want to find out more about your work, they want to find your books. So if you enjoyed this conversation, then I really recommend checking out Donnie's books as well, because they're really fantastic. So where can people find you, and where can they find your books online?
So they can find me on Twitter, Donnie Walls, just my name, GitHub, same thing. And my books are practicalcombine.com and practicalcoredata.com. I'm sure we'll add them in the show notes. And yeah, that's the most important places to find me.
Excellent. Yeah, there will definitely be links to all of those things in the show notes, and make sure to go check out those books if you're interested in those topics. In the show notes, which you can find at swiftbysundell.com/podcast/93, you will also find links to this episode's two great sponsors, which were Bitrise, where you can go to set up really rock-solid continuous integration for your app. Really important with all the things we talked about around testing and those sorts of things, to have really good continuous integration. And you can find that at bitrise.io/swift. emerge.io/Swift. And if you're interested in shrinking your app's binary size and to keep an eye on it and get continuous reports on how different changes affect your app's final size, you can head over to emergetools.com to find Emerge, a new tool which can help you keep your app size in check. Quickly checking out either of those two sponsors is a great way to support this podcast, so I hope that you'll find the time to do so. But regardless, thanks a lot for listening, and I'll talk to you again on the next episode.